Hello and welcome back to part 2 of the breakthrough tutorial for GameMaker in GML. So last time we got the core of the game working, all of the movement and collisions. And now we'll be implementing a lot of the effects on things like the score and the lives. We'll have the bricks actually destroy themselves when they get hit, and we'll set up our winning and losing conditions. And finally, we'll also polish everything off with some sound effects. So let's start off by setting up the score and the lives. So to do this, what I'm going to do is make a whole new object, and I'm going to call this obj control, because this is going to be the kind of controller object for the game. So it's going to be taking care of all the important variables. So now I am going to get the controller object to when the game starts. So I'm not going to use create, I'm actually going to use a different one, game start, because we're going to actually have high scores in the game. So right at the start of the game, I'm going to declare some variables, but I'm actually going to make these global variables. So I'm going to write global.playerscore equals 0. And now global variables are kind of special. So whereas, for example, this variable right here, the speed variable for the bat, that variable can only be accessed by the bat. And in different objects, we can set different speed variables. It's not like they're going to interact. The bat object doesn't know the speed of the ball object. But this one, a global variable, can be accessed within any object, and it doesn't get destroyed when that object gets destroyed. So this kind of persists throughout the game. So you can use globals for some important variables that you might need different objects to be able to access. Like I said, you can still get access to other objects' variables, but this can kind of make it easier to organize. So we're going to make a couple other ones. So global.playerLives, and I'll give the player 3 lives to start off with, and global.highscore, and we'll set that to 0 as well. And now I want to actually draw these to the screen. So we're going to add a new event, draw, and in here we're going to draw these to the screen. Alright, so we can use draw text to do this, and now you can only draw things in the draw event. So I can't draw things, for example, in the step event. You have to do it in the draw event. So in here, as you can see down the bottom, it takes in an X and Y position, so that's where the text will be on the screen, and then a string. So now I'm going to draw this up the top left corner, just a little bit off from the very top. So we're going to do 8, 8. And now, as it says, we want a string. So there are different kinds of variables in GameMaker. So there are numbers or reals, and then there are strings. And we write a string like this, so in these quotation marks. So now I can write score. But I don't want to just have the word score, I also want to put whatever this value is. But as you can see, currently this is actually a real number. So we have to convert it to a string. So what I'm going to do is add, because you can add strings together just like you can add numbers together, and it's just going to kind of add 2 words together. So if I put global.playerscore, as I said, that's a real number, and we can't add a real to a string. We have to add a string to a string. So we have to convert this into a string. Alright, so let's test that. So remember, we haven't actually added this object to the game, so let's come into the room and we'll add it in. Now, it doesn't matter where this object itself is in the room. It could be over here. It doesn't really matter, it's just going to be drawing things to the screen. But the convention for objects like this is to put them at the origin, so it's 0, 0. Alright, let's run the game. There you go, and our score is coming up here. Now, this font is a little bit boring, right? It's just the default font. So how about we set our own font for this? So let's come over to fonts and create a new font. And I'm going to call this FNT Game. Or you could call it FNT Text, whatever you want. And then just pick whatever font you want. I might just go with Impact, make it nice and big and punchy. I'm going to change the size up to 30. Yep, that's fine. And now, what we're going to do is set that font. So before we draw the text, we're going to have to set the font. So draw, set font. And by the way, if you're ever kind of wondering if there is a function that might help you do something, so for example, anything to do with font, you might just want to type in the word font, and then the autocomplete might give you a bunch of functions you want. And then from there, you can look in the documentation to see what they actually do. But the one we want is draw set font. So that will change the default font that we're using. And we want this to be FNT game. And now we actually only need to do this one time if we're just going to be using this font throughout the whole game. So we don't actually need to put it here because the draw event, just like the step event, is run every frame, right? This needs to be drawn to the screen every frame of the game. So we don't need it in here. We don't need it to be performing that function over and over again. We only need it to do it once. So we can put it in the create event or the game start. So now if we do it, there we go. Our font is different. Let's also draw the high score. So I might just copy and paste. But instead of this location, let's do it at the other side of the screen. So I'm going to go room width -8. And we're going to have high score. And here, high score. So if you want to just check if this is working, let's just say the high score is at 100 for now. And see if that works. So it's writing something over here, but you can see the words are kind of anchored to the left. So it is drawing it at the right place, but because the text is anchored here, it's drawing it over here. So what we can do is change the horizontal alignment with draw, set, H-align, and then if you middle click on this, you can see what we have to give it. So at the moment, as it says, the default value is FA left, but if we want it here, then we say FA right. So we go FA right, and then after it draws this, we actually want to set this back to normal. So FA left, otherwise it's going to keep being at this alignment, and then once it comes around to draw this again, it will be at the right. So let's have a look at that. And there we go. All right. Now, one more thing that we should draw is the players' lives. And I might actually draw this down the bottom. And instead of drawing numbers, how about we actually draw sprites? So we could draw the player's bat, kind of like the hearts in Zelda. So what I'm going to use is draw sprite. And that's how we can actually draw a sprite. And we're going to draw the bat. So we can go draw sprite, and then it tells us what sprite do you want to draw. So we want to draw SPR bat. And then it is asking for the sub image. And if we come over to the sprite, so I'm just going to middle click on this. The sub image is actually talking about what frame of the image to draw. So you can actually have animated frames and add frames like this. And the sub image is asking what frame do you want. So we want the first one. But now I don't actually want 1 because like a lot of things in programming, the sub images actually start from 0, not 1. So the first one is actually 0. And now the X and Y, well, if we have 3 lives, then we're going to actually want them in different positions. But for now, I'll just say room width over 2. And for the Y, we'll go room height -16. So we'll just get 1 drawing at the moment. So now if we draw that, that's what it's going to look like. But maybe just so we don't get confused, let's just draw it a little bit invisible and a little bit smaller than the real bat. So instead of using draw sprite, I'm actually going to use draw sprite ext, and I might just do this over multiple lines so that we can see all of the arguments. So as you can see, the function now is requiring more arguments from us. So now it's asking for the X scale and the Y scale. And if I bring up the documentation again, the X scale and the Y scale is kind of how big the sprite is. So for example, if we shrink the Y scale to be 0.5 instead of 1, it's going to kind of squish the sprite. So that is what we want to do. Let's shrink it a little bit and say instead of 1, let's go 0.75. Now the rotation, I don't want to rotate it at all, so I'm just going to put 0. The color, so this is kind of the image blend if we wanted to tint the sprite. So you can do that if you want, but I'm going to keep it at the default. So I'm going to put C white because that's kind of like no tinting. And now finally the alpha. So that's why we wanted to do this. So the alpha is kind of like the transparency of the image, and it goes between 0 and 1. So if you are at full alpha at 1, then the image is completely opaque. So it does not look see-through. And the closer we get to 0, the more transparent it looks. So we're going to pick a value that's a little bit less than 1. Let's go 0.5. All right, so now if we draw that, there we go. So that's a little bit better. But I want it to draw however many lives we have. At the moment, we're just drawing 1. we haven't actually used this variable right here. So what I'm going to do is I'm going to use something new. I'm going to use what's called a repeat loop. And this will perform a code multiple times. So let's wrap it in here. So I'm going to highlight all of this and tab it over. And now it's going to repeat this bit of code however many times I put in here. So if I put 3, it's going to do it 3 times. So now what I can do is draw this and have it repeat by however many lives that we have, because then it will draw that sprite by however many lives we've got. But each time I do want it to vary the X position, because at the moment this is just going to draw 3 sprites on top of each other, which is not what we want. So we want to change this value right here. So I'm going to change this. We're going to be altering the X value. So instead of just a value, I'm going to put a variable. So underscore X. And now we are going to set that up here. So underscore X equals room width over 2. And then what I can do in this repeat loop is increase this value. So down here, once it's drawn it, I can say increase our number. So I can plus equal, so make underscore X equal to itself plus, let's just say 64. So if global player lives is equal to 3, then this repeat loop is going to run 3 times. It's going to draw the sprite and then it's going to increase this value for the next time. And it's going to keep drawing them. So if we run it now, there we go. We kind of have it going off to the side. But if we want it to be centered, then we're going to have to shift this over kind of by half the number of lives that we have. So let's go through this in our head. So for example, if we have 3 lives, then we want to not just start at half the room width, we want to also subtract half the amount of space that these are going to take up. So to calculate that, we need to get half the number of lives times this by however much we're kind of shifting it over by. So we want to go minus global.playerLives over 2, and then we'll times that by 64. Or what you could do is just go times 32 because these will cross out. Because if we half 64, that'll be 32. Now, if we run that, that's actually not quite right, as you can see, because we don't want to count the very first one. The very first one now isn't in the correct position. So we're going to subtract 1 from this, and we'll just put that like this. And one more time. There, now we've got it. All right. So now all the variables are set up. Now, when the ball hits a brick, we want that brick to be destroyed and we want our score to go up. So, we know that when the ball collides with a brick, we want that brick to be destroyed and we also want to add to the score. So we can come over to the OBJ ball, and when it collides with the brick, let's say that we will also add to the player score. So global.playerscore plus equals, and let's just say 15. You can put whatever number you want. And we also want to destroy that brick. So to get an object to destroy itself, we can use a function called instance destroy. And that will destroy whatever instance is running this code. So at the moment, what would actually happen is the ball would be destroying itself, but that's not what we want. We want the brick in this collision to destroy itself. So remember how we can use the keyword other to mean the other instance in this collision? So the brick, we're going to get the brick to run this. So this function can actually take an argument. It doesn't have to, but it can. So we can give it an instance to destroy. So we can just say destroy the other instance. Another thing I'm going to add in is over the course of the game, to make it a little bit harder, I'm going to increase the speed of the ball. Then the way I'm going to do this is every time we hit the bricks, I'm going to increase the speed of the ball. So I'm going to say speed plus equals 0.1. And you might want to set a kind of max speed so that it can't go past a certain speed. So for example, if speed is less than 12 and only then we'll let it increment, or you could just let it increase to as fast as it can possibly go. So now, if we run the game, when we hit a brick, our score should go up and the brick gets destroyed. Alright, so it's starting to turn into a real game. So what we also want to do is, if the ball goes below the bottom of the screen, then we want to take away one of the player's lives, and we also want to kind of reset the ball so it comes back to the player and it gives us another go at the level. So to do that, we can come back to that intersect boundary code that we had, and in here we can now subtract that life. We just go global.playerLives and we can minus equal 1. So another thing that we want to do here is we've taken away a life, but we also want to have the ball come back to the player. What we can just do is destroy this ball that has now gone beyond the boundary. So we'll call that instance destroy. And we can then create a new ball back at the start. So we can use the function instance create. And now there's kind of two options here. So we can create an instance at a particular depth or a particular layer. We haven't really talked about depth. We've talked about layers. So let's just use that layer one. So we're going to put it into that instances layer that we know exists in the room. So now it's asking us, what X and Y location do you want to create your new instance at? And we actually want to put it at the starting X and Y position of this ball. So we can give it X start and Y start because that has saved kind of where this instance was created. Now it's asking for a layer ID or name, and if you look at the documentation, it lets us give the instance layer's name as a string. So let's just do that. We call it instances. If you didn't change the layer name, that's what it'll be called. And the object that we want to create is another ball. All right, so that's kind of deleted the old ball and made a new one at the position it was at the start, and it'll have all of these variables reset. So it should be ready to go. So if we give that a go, one of the lives got destroyed and the ball appeared back at the player's bat. But now, actually, if the player has no lives left, then we want it to be a game over. And at that point, we want to check if our actual score is higher than our high score. And if it is, we want to kind of save it in there. So something else that I want to check here is after this is done, if global.playerlives is equal to 0, and now we could just put is equal to 0, but I might just put less than or equal to 0. And this is just if for some reason this has gone below 0, it's going to still catch that in this condition. So a lot of the time we do that just in case there's some kind of bug with the program or there's something that we didn't anticipate influencing the variable when it shouldn't be. This will still be fine. So if we have no more lives, then I'm going to check if the global.playerscore, if that is larger than global.highscore, then we are going to set that as the new high score. So we're going to go global.highscore equals global.playerscore. Alright, so that will set the high score, but now we actually need the game to reset. So now, in the event that we don't have any more lives, I do still want that ball to destroy itself, but I don't want it to create a new ball. So I'm actually going to move this up to here, but I'm going to put this in what's called an else. Which basically means, and I'm going to just delete this like that. So basically, if this check is true, it's going to run this code. But else, so if it's not true, it will run this code. So if we still have lives, it's going to be destroying the ball and creating a new ball. If it doesn't, then we're going to be doing this check and we're not going to be creating a new ball. And the other thing I want to do is in this case, we've kind of made the game unplayable because now there's no ball to move around and we're kind of just stuck there. So I want to kind of put the game in a state where we can restart the game when the player is ready. So I'm actually going to say at this point, we're going to freeze the game, and then as soon as the player presses a button, we're going to restart the game. So I'm going to have to toggle something within, let's say, the control object to basically say, yes, the game is over and now we are waiting for input to restart. So in the control object, I'm going to have a variable called gameOver. I'm going to set that to false, of course, to begin with, but during this, I'm going to set it to true. So in here, and I don't want to put this inside this check because it's going to happen regardless. So this is just the check for the high score. But in either case, if we've got no lives left, then we do want to toggle that value in the control object. Now, it's not enough to just say game over equals true. Because remember, this variable doesn't belong to our ball, it belongs to the control object. So we're going to have to access the controller and have it do this. So I can just go obj control.gameover equals true. And then within here, we can add something in the step event and just say if gameover equals true. And actually another way of writing that is just to say if gameover, because you remember if checks are just checking if whatever is inside this curly bracket equates to being true. So we could check a condition in here, but if this variable is equal to true, then that's also going to satisfy this condition. So if game over is true, then we are also going to check if, and now we're going to check for a keyboard press. So if keyboard check pressed, and now I'm going to say any key at all can be pressed to restart the game. So this is kind of like those key press events, but like I said, we can include this in a step event, and I just kind of wanted to include an example of the fact that you can do that. So in the case that game over is true, we're going to check if VK any key. And again, you can middle click on this and bring up the documentation to see what the different keys are actually called. And we can go to keyboard input, and these are all the keys. And we're going to use this one, VK any key, to say that any key is being pressed. Then we're going to run room restart. So now this is going to restart the entire room as if it had just been entered. But this is just the room, not the game. So this event right here that was setting the preliminary kind of scores is not going to be run in the event of a room restart. So we're not going to be overriding the high score or anything. So I'm just going to change this back to 0, and let's test that high score being updated. So we'll just hit it a few times and die. There we go. So now the game is kind of in frozen mode, and if I press any key, it should restart. There we go. So it restarted the level. And our high score is being updated, but actually we also want that score to be reset, which we forgot to do. So let's go back to the control and say in here we also want to restart the player score to be 0. All right, let's run that. There we go. All right. And we also want to give the player all of their lives back. Now, there is another instance where we want to be restarting the room, and that is if the player has destroyed all of the bricks. So what we can do is be checking if the number of instances of the bricks is 0, then we want to restart the room. And we wouldn't be resetting these variables because we kind of want the player to be able to continue playing until they do die. And now there's a way to check for the number of instances or something. Instance number of a certain object. So the instance number of the brick, if it is less than or equal to 0. Again, that's a case where it really shouldn't be below 0, but just in case, then we will restart the room, but not these. All right. So now you may or may not have been noticing some strange behavior with the ball and its collision. So it is actually possible for the ball to get stuck along the walls of the room because of how we've coded it so far. So it shouldn't normally do this, but it is actually possible for the ball to go so far over the boundary that when we flip the H speed, it's not enough for the ball to get back outside the boundary of the room, and it will flip it again and again, and it will kind of just stay over the boundary of the room, not quite able to get out of it. So in that case, what we're going to do is first, so if it has intersected with the boundary, so whether that be just 1 pixel over or quite a few, because remember the ball can be going quite fast, what we're going to do is move it right to the edge. So we're going to clamp the ball's position. So I'm going to say x equals clamp, the value that we want to clamp, and now the minimum and maximum value it can be. So we want to say basically the minimum is 0, and then we want to plus the sprite x offset. Because remember, we don't want any of the bounding box over the intersection. So actually we don't need 0, we just need to put sprite x offset. And now the maximum will be the room width minus that sprite x offset. So now that will return the x value but clamped between these two. So we shouldn't be getting that bug. And we can do the same for the vertical speed. So again, this is something that isn't obvious when you're first coding it, but you might notice that problems arise while you're coding, and this is kind of a thing to fix the bugs. So we're going to just clamp that, but instead of the height, and we want the y offset. All right. Something else I want to add is power-ups. So when we hit the brick, I want there to be a chance that a power-up is going to appear. So for example, in these games, we have a power-up that could increase the size of the bat to make it a bit easier. So first off, just like we kind of did at the start, we are going to add a new sprite, and I'm going to call this SPR powers. And I'm going to change this to 32 by 16. I'm going to leave the origin there, it doesn't have to be any different. And I'm I'm going to create actually 2 frames for this. So on the first one, I'm going to have a getting larger arrow. So it looks like it's getting bigger. And I'll color it yellow. And I'm also going to add a new frame, so I can right click and add new frame or just click this one. And I'm just going to draw 2 arrows here. And the reason I'm kind of putting this in the same sprite is that we're not going to make 2 different objects for the 2 different power-ups. We're going to have one power-up object, and then depending on what subimage or image index it has assigned to it, so kind of like which of these 2 frames it's actually showing, that's going to determine what effect it will have on the player. So we're going to create that object, obj powers. Just as before, we'll assign that sprite to it, but in its create event, we're going to have it randomly select from one of those 2 image indexes. So the way we do this is we use image index. This is going to set what frame our sprite is kind of animating at. So image index equals and then choose either 0 or 1, just like we kind of chose the colors before. And the other thing we're going to want to do is this is actually an animated sprite, so it will actually animate like this if we let it. So I'm going to actually set that speed for this object, the image speed, equal to 0 so that it is not animating. So when this object gets created, I'm going to get it to slowly descend down the screen. So I'm going to set its direction, and we're going to want it to go down. And remember, the angle for down is 270. And now I will set its speed to 5, so that should have it moving downwards. So now we have to think. 2 things can happen. So either this is going to collide with the player, or it's going to miss the player and continue outside the room. And now this is an important thing to consider. If something is outside the screen, that doesn't mean it stops existing unless you tell it to. So there's a possibility for us to be making lots and lots of power-ups and them to be moving outside the screen. And in that case, they don't need to be existing anymore. They're just kind of taking up memory for the computer. So we can delete them. So let's add an event. If it goes outside the room, I want it to destroy itself. So that's just kind of a little bit of cleanup that you should keep in mind if you're making objects like this. Now the other case is, of course, it does actually collide with the bat. And now, depending on what kind of power-up it is, so if its image index, if that is equal to 0, so that first frame, because remember it starts at 0, then we want to make the bat larger. So if the image index is equal to 0, so remember the double equal sign, then what I'm going to do is have the bat increase its image X scale, because remember the image X scale is kind of the horizontal scaling of that sprite. So we could increase that image X scale to 1.5. But remember, again, image X scale in this context belongs to the power up. But we want the bat to be running that code. So now, again, we could go objbat.imageXscale. But another way to do this, I just want to show you, is using a with statement. So with objbat, and then opening this curly bracket, like this. And now when you use a with statement like this, it's kind of as if you go into a different object and you have it perform this code. So everything outside these brackets, the powers object performs. Anything inside here will be performed by the bat. And you will want to use this instead of the dot operator if you want it to be performing a few lines of code. So actually that is what I want it to do. I want it to be setting its X scale. But another thing I want it to do is I don't want this power up to be lasting forever. I want the power up to just last, say, 10 seconds. So what I'm going to do is introduce a new thing that we haven't used yet. So what we're going to do is actually use the alarm functionality. So let's just head over to the bat. And let's add that alarm. So alarm 0, so as you can see, you get to use up to 12 alarms. We'll just use that one. Basically, we can set that alarm to go off after a certain amount of time. So here we can set that alarm to go off after 10 seconds, we could say. Except this is actually going to set it off after 10 frames. If we want seconds, then we can multiply this by the room speed or the frames per second. So that will multiply 10 by 60, and after 600 frames, that alarm will go off. Of course, at the moment that is empty. So let's come over to it and actually put something in here. So we want to reset the image X scale back to just 1. All right. Now though, we had a different image index as well. If the image index isn't 0, then it must be the other one. So we can use an else case here. Else. And now for this one, I'm going to slow down the ball. So remember how the ball was speeding up every time we hit a brick? Well, I'm going to have this power up change the ball speed. So let's go objball.speed back to whatever it was originally. So let's just say 3. And actually you might want to have that as a variable. So we were using just a hard-coded number. Remember, and we were setting it here, but you might now want to set that as SPD. So that now when we come back to here, you can just set that to speed. But now this speed at the moment just belongs to obj powers, but we want it to belong to obj ball. So instead of doing a dot operator, let's do a with statement again and have the ball perform this. And regardless of what is happening here, what we also want to do is just destroy the power up. Alright, so now that's all set up, but we actually need to go ahead and spawn it in the event that we destroy the brick. So let's come over to the collision with the brick. And in here, we also want there to be a kind of random chance that it's going to spawn a power up. So we could do it from within here, or we could actually do it in the bricks destroy event. In the event that it gets destroyed, we can spawn that. And we're going to use another randomize function to do this. So we can use if irandom. So we could use irandom range again, but let's just use irandom so we know what this one does. So this one will return an integer, right? So the I, so this is a little bit different to just random range. So this is an integer or a whole number it's going to return. And now we can just put one number. So for example, 2. And this will return a whole number between 0 and 2 inclusive. So whatever this number is, it's going to include that in the possibilities. And we could say if irandom 2 is equal to 0. So in the case that it is equal to 0, then we will spawn that power up. And if you increase this, this is going to decrease the likelihood that 0 will be the number returned. So at the moment there is a 1 in 3 chance because it could either return 0, 1, or 2. So I'm going to leave it as that. So now we will spawn that power up. And the location that we want to spawn it at, let's just say, is the location of the brick. So we can use the brick's X and Y position. And we'll say in the instances layer, and the object that we want to create is obj powers. All right. And since we've been using so many random functions, you might be noticing that as you're testing your game, it's actually running the exact same way every time. So even though there's a lot of bricks in the room who are choosing what color they're going to be, it's always the exact same, which seems a little bit, well, not random. And that's actually because GameMaker is using a randomly generated seed to use whenever we use the random functions. That seed is going to be kept the same for this project unless we tell it not to. So if you want, what we can do is in the create event of obj control or the game start, we can say randomize if you want that to change. Let's give that a test. So now you should be getting different layouts for your bricks and everything should be a little bit less predictable. So really that's most of the game done. And now what we can do is just add some sound effects to polish it off. So there are some sounds that come with the tutorial that you can use, or you can use your own. So I'm just going to open up my folder where I am storing the sounds. I'm going to highlight all of them and then just drag them into the project, into the sounds. So you can see I've got a bounce, click, explode, and power up. And now I'm just going to get those to play when those events happen. So let's do bounce first. So we're going to play that when the ball bounces against the boundary of the room. So let's go audio, play sound, and that will play the sound. So now we want the sound ID. So we called it SND bounce. Now the priority, and this is kind of if you have competing sounds playing at once, the one with the higher priority is going to play. So it's a little bit arbitrary what number you choose here. I'm just going to put 1. And we want false for loops. We do not want that looping. And I'm just going to copy that and I'm going to add that to the bat collision. And in the brick collision, although I'm actually going to use a different sound. So I'm going to use SND explode because we're actually going to be destroying the brick. Now for the power up, I'm going to go back to the power-ups and we're going to play the power up sound. So sound power up if we have collided with the power up. And lastly, the click sound. And I'm going to play this one when we start the game and press spacebar for the ball to move off. So for that, we had it in the ball object in here. So if we hit space, so we're going to go sound click. And I might also put that in the game over, just to give the player a little bit more feedback when they hit that button. So that was in, I think, the control in here. So if it was in game over and we press any key to restart the game, let's also just play that sound effect. All right, so that should be everything. Let's give the game a final run. There we go, so our sound effect worked. There we go, so it looks like all of our sounds are working. So now we've actually reached the end of the tutorial. Now it's just adding more content to the game. So for example, you might want to make more defined levels. You might design the bricks to be in particular places. You might have bricks where the colors actually mean something. So for example, you could make it that all of the red bricks are destroyed in one hit, but the blue bricks take 2 hits to be destroyed. You might want to make more levels. You might want more sound effects. You might want a little track to be playing. You might want to add a background to this. You could add a start menu, a game over screen, all of that. So congratulations on making Breakthrough. I hope you enjoyed it, and I wish you the best of luck on your game making journey. Perhaps I'll see you in another tutorial.